Good day, everyone. My name is Prince Macaro A. Francisco from SPCPE 1A, and today I will introduce to all of you my case study for computer engineering as a discipline. My case study is called Context Aware Lighting Adaptive Dimming System for Energy Efficiency. Now, this is a smart lighting system that automatically adjusts the lighting based on the brightness or the motion of the environment in order to save energy. This system focuses on reducing unnecessary electricity waste. Now let's start with our problem and background. Background and problem. We know that we use lights everywhere, right? But there is a problem. Sometimes we waste unnecessary energy. Like, for example, when you leave the house and you forget to turn off the lights, or in the streets. When there's no people, but light streets are using 100% power to light the environment. That's why in our problem statement, it states here that lights waste electricity when they stay on unnecessarily. Also, the basic automatic lights are only on and off, and there is no dimming, means energy is still wasted at nights. That's why we have the goal to create a smarter, more efficient lighting system. Now, let's start on how it works. First, it works by using the three states lighting logic. Number one is the daytime, which is the lights are off. This is where the LDR detects the brightness, and if it's too bright, the Arduino will say that the light should be turned off. Next, the night with no motion or the dim. This is where the light detects low brightness from the environment, but there is no motion on the environment. This will cause the light to be low using the PWM method. PWM method, this will be used to make the light look dim. Next is we have the light with motion. This is where the light detects brightness and also the motion that will cause the system to fully turn on. Next, these are the key components of the system. Number one is the LDR. This is what we use to read the brightness of the environment or the light intensity. Next is a PIR sensor which detect the motion from the environment. And of course, we have the Arduino Uno. This is the main processor of the daytime, also work on the three-state logic. Next is the MOPSET for making the PWM trick possible. Um, this is where what controls the LED to make it dim or fully bright. Next is we have the LED strip, which is the light output, which is also possible to be dimmable. Next is we have the resistor, breadboard, and jumper wires. This is used for sport connection or making the connection possible. And then lastly, we have the external power supply, or this, of course, we have the power supply to make the system work or powers the system or the LED. Now let's talk about our flow chart here. Our flow chart will start, and then the LED LDR rather will read the light intensity from the environment. If the light intensity is high, then that means that it's day. So it will make the light state into 0% power. But if the light intensity is low, then it will read the motion from the PIR sensor. After reading the PRR reading the motion, it will ask again. It will make a decision if there is an emotion. If there is, then the light state will be 100% on or fully bright. And then after that, it will set a timer, which is a 10 seconds timer. Then it will make a decision if the timer is expired. Then if no, not yet, the timer is still going, then the light will stay on 100% and then the loop will begin from the start again. And then after that, it will ask again for the motion, for the LDR. Then if the timer is expired now, it will then use the MOPSET or the power control switch, which will use the PWM trick to make the light dim or 24%. Then after that, it will loop again from the start. So that's how this system works. Then lastly, we have the ethical impact, of course. This system um, reduces the electricity waste. Also, it lowers the carbon footprint, which is because when we use a lot of electricity, there is more used carbon. That's why if we lessen the use, if reduces the use of electricity, then it will also lowers the carbon footprint. And of course, it also provide a safer, responsive lighting because it doesn't constantly use fully 100% power. So that's why overheating is less possible. Then the reflection, the most challenging for me, is thinking of a unique idea. And the hardest part is the creating of the flowchart because you need to think critically. And of course, this case study also improved my problem solving and my critical thinking. Thank you for listening, and that's my case study for computer engineering as a discipline.